Okay. Good evening, ladies and gentlemen. I have to excuse myself first because I have a sore throat and I might sound a bit strange tonight, but I hope you will get over that. The topic that I would like to talk about tonight is easy software installation on a variety of operating system platforms using a system called package source. When you're installing open source software in a traditional Unix environment on Unix or Unix-like systems, you know that there are a number of problems, like there are many programs and there are a lot of version changes, so you have to reinstall certain things every week or so. When compiling from source, and especially if you have not the very latest hardware, it's very time intensive, so compilation just costs time. Also, if you're not exactly working on Linux and nothing else, if you're working on Solaris, if you're working on some BSD version, you may encounter the problem that software is today not really written with portability in mind. And a lot of things could be said about writing portable programs here, but I will save you from that. Next thing is that installation of software itself, it's not a trivial task. You cannot tell your mom, okay, this is some Linux system or some other Unix system, and hey, it's no problem installing OpenOffice or something, especially not from source. Because, well, at least you need some basic knowledge about the tools, and there's always a number of ways to start configuring things like the GNU autoconf mechanism or IMake, XMKMF, and so on. You have to know these things, how they work and what to do. Then there are a number of side effects, like one package depending on many other packages, so you have to go down and install all these pre-requirements first. You know, you need to know maybe some compiler switches to optimize or get things just going as like you want. Yeah. There are also a number of interdependent packages, like GNU autoconf is very flexible, it detects things if they're installed or not, and the behavior of software will be really different based on the fact if a certain package is installed or not, and you may just not be aware of that interdependency here. And last, troubleshooting really requires expert knowledge. If something goes wrong, my mom won't know how to fix a compiler bug or a make bug or just what a makefile is. And same thing with precompiled binaries that may lead to similar problems here. This is what software interdependency looks like in practice. It's pretty scary, isn't it? It's from a system running NetBSD, and the biggest thing is located on the bottom of this graph here. It's KDE, and you see a lot of bubbles here, which are all the requirements for KDE, like KDE base and graphics and network and stuff. And then KDE libs and all the libraries needed by KDE in turn. So this is basically just a KDE setup. No fancy applications beside the desktop here. And still, this is really scary, I would say. Maintaining this. Now, you're probably following open source development. There have been TIFF bugs recently. There have been bugs in all sorts of libraries. And these libraries are all in the very lowest layers here, where everything is based upon it. And if you have to do some upgrading, the only thing that you can assure the binary compatibility really works is by recompiling everything. And this is, of course, not really fun. So you might really consider, what do I want to do? There are several types of systems. The classical Unix system is a really small operating system that comes with very few things that you have, and where you have to install all the applications yourself. Well, this is, of course, difficult to install. But the advantage is, if you have to maintain it, it's all in your hands. and you're not depending on some vendor that you have to wait for. On the other side of the scale, if you take a system where applications and operating system are very tightly coupled, well, you get basically everything that you need, and you have to install very few things on your own. The benefit of this approach is, of course, the systems are really easy to set up, but if you try maintaining this system on yourself, you will have a lot of fun because things just don't work out as you expect them to, because of these interdependencies in packages and all sorts. Typical systems here would be some desktop systems like SUSE Linux or Red Hat, maybe Mandrake, or Windows to some part. Sorry. There are also some hybrid systems which come with a rather small application-based operating system and some applications, but which enable it to really make it really easy to add applications and manage them. So they are easy to install and also easy to maintain. Example systems here would be from a DSD corner, also Debian Linux or the Gentoo Linux, which have also quite interesting package management systems here. So if you look at these systems, well, what do you want? When you want easy installation, you have the choice to choose such a system that doesn't need a lot of maintenance. Then you use some ready-to-use binary distribution, for example, for a desktop operating system. Windows or SUSE Linux is just fine. You install it from CD and you're happy. Your mom is happy. She can use OpenOffice, click on the printer and it will print. It just works. I mean, of course, she will do some web surfing and certain security problems will arise, and then this is where maintenance starts. This is where the fun starts. On the other hand, if you have some server that you have to maintain because it has to be really secure and you don't want some buffer overflows to harm your company or your boss's company, you need a system that's easily maintainable. And in such an environment, you usually just have a few packages, not a really lot as we have seen in the previous graph, but usually just a few packages. But still, there are lots of interdependencies there. Well, for such an approach, take a good operating system that's small, not too big, and then just install the important packages on your own, like compile your own web server on Solaris or add Apache and PHP. So this is usually a workable solution. Of course, you can use something else in Solaris. Well, so you have either easy installation or easy maintenance, and well, for the people that say, oh, can I have both, please? There are some approaches to this, and one of these approaches I would like to introduce to you tonight. This is the package source system. So it's also, well, we call it a cross-platform solution package source. What is it? It's a system for easy installation and updating of packages which are based on sources. It's a source-based package management system. No precompiled binaries, you can do that, but the base system really compiles from source, from the open source packages available on the net. You can create binary packages if you want. You can install binary packages with the system, of course. I mean, when I set up my mom's workstation, I don't want her to compile OpenOffice for 2 days, so I need that. But if you want a system that's really flexible, you need to have compiling. The components of the system itself, it's a small set of management tools and a rather big packages collection, which is basically well-built instructions for packages, how to install packages. And this is really what's hiding behind the name package source, because it's really a source, an instruction set of how to build packages, package source. One thing that I usually get asked from people is, does it handle dependencies? Well, in the age of Gentoo Linux handling this properly, it's slowly starting to get the usual thing that dependencies are working properly in Linux land. I think that was a problem for quite some time. And yes, of course, package source does handle dependencies properly. If you just do a make install in the KDE directory, it will take care of everything that you need. You don't want to know that. Why would you? You want KDE, you want the desktop and use it, or often Open Office or something. You don't want to bother with all that graph shown. No, that's too much complexity. You cannot handle that. So this is all the complexity is just taken from you by the package source system. A bit of history on the system. It was originally ported from the FreeBSD operating system to NetBSD. NetBSD, as you may know, is a very portable operating system to a number of hardware platforms, not only Intel PCs, but also Alpha workstations, Power Macs, UltraSparks, small embedded devices, and so on. And NetBSD has a very strong focus on portability and getting one source working everywhere. Well, and this was just extended to get source for one open source project, be it KDE, Mozilla, or something that was not written as portable, going on as many platforms as possible, and also extending this to several operating systems in a later step. And well, this is what package source is today. It has been ported to IBM's AIX, BSDOS, Darwin, FreeBSD, IRIX, Linux, NetBSD, OpenBSD, Solaris, and, funnily, Microsoft Windows. Yeah, there is a package called Microsoft Services for Unix, and this is also known as Interix. And on this Interix, you can use package source, so you don't have to do a lot of things. I haven't played with it, but the theory is you go in the GIMP directory for the graphic image manipulation program and type make install, and you have GIMP on Windows. At least that's the theory. From the Linux distributions, we know that package source is working on SUSE 9, Debian, Root Linux, Slackware, Red Hat, Mandrake, and Bluewall. The Bluewall Linux distribution uses package source as its native package system, so it's really cross-platform here. Maybe a few details. If you wonder, hey, how can I use this? How can I start using it? The basic steps are you just grab the package source collection. I will show how to do that. Get the binary bootstrap kit working somehow. That's the management tools you need. There are precompiled binaries available, or just from feeling, I prefer compiling this on my own, and I will show the steps for this too. And after you have the management tools, then you can just say, okay, let's use it. Go to the package source www Mozilla directory, and then type make install, and it will install Mozilla. Of course, it will all do the other steps like installing dependencies first, grabbing the source code, and so on. We get to that in a second. But really the basic steps, you need the things somehow, you install the management tools, and then you use them. Change to some directory and make install. The steps in detail, there are two ways to grab package source. One is shown here, to use anonymous CVS from the NetBSD server of the NetBSD project. Using usually as SSH, but you can use pserver somehow. And if you run that command, it's kept generally enough so that it should run everywhere. Well, it will just unpack all the packages collection, and the alternative way is you grab a so-called tar ball, a big tar file, which has all the data in it, and just extract it so you don't have to use CVS, like if you have no network or something. After you have fetched that, you need the bootstrap kit, the management tools. You have two ways to that. Either you grab a precompiled binary or compile it on your own. Precompiled binary packages, binary package kits are available for a number of operating systems platform used here. I'm not going to read this to you. The package source project has, in the meantime, its own web server project website, where you can also read these and download these information. So this is updated daily. So if something changes here, well, you'll notice. The other way, if you say, okay, I don't want to compile the I want to compile the thing on my own. I don't trust them, what I did in these binaries. That's no problem. This may look a bit complicated here, but really what you want to do is change to the package source bootstrap directory and then just call the bootstrap script with a few parameters. It's really the prefix which you know from GNU configure. I've put a variable local base here and I use several other variables here, and into this directory this could be user local on a Linux system. The example I'm using here is paying very close attention that I'm not requiring root privileges. So you can operate package source without root privileges. This is a very fine thing. If you do software installation on a large setup, you know that your software isn't scattered around the system, so only where you can write. So you give it a definite prefix where it will install packages. pkgdbdir is where the management package internal information is stored. And well, if you do this as non-root, ignore user checks, so you don't get any complaints. It will then start running GNU configure on a number of things and compile and compile and compile. At the end, it will also put some things into place and then give you a few instructions like set your path variable to the path that you've just said, extend your man path so manual pages are found. There's also some mk.conf file which has some default settings which you can change later. And also, of course, a pointer to package source documentation so you know how to go on compiling. Well, after that, the basic infrastructure for using package source is available. So it's really just that bootstrap command. After that, of course, you have to adjust your search path for the shell so it will look in the right directories and set this environment variable. So this is where the package management tools will look for management information. After setting these two variables, you can run the package info command. This is one of the package source commands to list the number of installed packages, and you will see, hey, there's already one package installed. Whoa, it worked. The digest is used internally for checksum calculation. So you already have your first package installed that way. Maybe having a small look at what was installed now, what is part of that binary bootstrap processor. In that given prefix directory, there are subdirectories bin and sbin. In the bin directory, we found a bmake command. This is a Berkeley compatible make command. It has nothing to do with GNU-make. This is really just two words. Basic functionality is the same, but BSD-make has a number of features that you cannot find in GNU-make, and well, we haven't been starting from that, and we've just used bmake for all the build systems. PAX CPIO tar, a GNU-compatible tar. This is here because some systems just don't handle a GNU-compatible tar out, like Solaris or so. Digest, this is a binary already installed from the package. The FTP command here is a special binary that can handle URLs, HTTP, FTP URLs. It's a very nice extension too. In the sbin directory, well, you find some management programs. The most interesting ones is probably package add, which can be used to install binary packages that you have created. Package delete to, well, delete packages. And packages info you have already seen to query some information about installed packages. The other ones, I have to admit, I usually don't run them anyways, and for some I don't even know what they are, so just leave them. So, after you have set up your infrastructure, you can start compiling packages. Most important thing is to remember, instead of make, you have to use the BSD-compatible bmake, because usually your system will have a make command and this will fail. It will just deliver you a couple of very funny error messages. You can't do anything wrong there, but you need to use a bmake command to get things going here. I'm setting one variable makeconf here for some default settings. To you need this to use package source as non-root. I will show a few example settings here. Well, after that, change to the package source directory, and I usually take the Figlet program, which is a small ASCII art banner printer. I type bmake to compile the thing, and in a second step, I can also do this in one step, just type bmake install to install the files compiled into the final directory where they are run. After that, when I invoke package info again, I will see, okay, the Figlet package is installed with a certain version and a short description of what the package does. So this apparently worked. If you want some of the details here of the compile process, this is what happens when you type make. NetBSD usually tries to do some vulnerability checking against the database that knows what programs do have security problems. You can ignore this, or if you're conscious about security, you can say, okay, I want to update the security database installing this package here, security audit packages, then download vulnerability lists to know, okay, what problems were found in which program now in the last few days, and maybe get a notice on security problems before you install source. Anyways, after that, I have already fetched the sources here. It will usually do that in the first step. After fetching the sources, a checksum is built, so you know that you have actually gotten the right sources and not something with some Trojan horses in it. Sources are extracted, maybe patched to run better on your target system. Configured, new configure if it's required, not for this package. And, well, built, compiled, basically. So this is all that's happened automatically for you. You just type bmake, and, well, it's made for you. You don't have to pull sources. There are no dependencies here. They are usually installed at this time, of course, too. And it just works for you. You don't have to know anything about the package itself. The installation step is just, well, bmake install too. Usually you do installation as root, and by using some settings here, I've said, okay, I don't want to switch over to the root account here because I want to maintain my software as non-root. And so the system is not asking for a root password here. The usual behavior is to ask for a root password. And, well, after that, the normal make install instructions provided by the packages are run. So putting the files into the final place where they are needed. And the package is registered, so you can query it and, of course, remove it again. And after these two commands, make install, the package is installed. You can then use it, assuming that you have already set the search path and everything. You can type Figlet, it's a shell feature, see where the program Figlet is. Okay, it's in my private package directory for a certain operating system. And now running the Figlet command with hello and querying the uname command to give me the operating system name, it just says hello Linux. So obviously it worked. So we have installed package management commands now and also use the package source system to install the Figlet program, and we have used it, so it seems it worked. Maybe going on a bit, I will show you a few more details on the system. It's just really details that you might be interested in. The first one is compiling without root privileges. We have used, or I've used that in this example. And I've used the makeconf environment variable to point to a certain file that has some settings. And that determines my user ID, my group ID, some of my directories where I put things. And these things are used later on to install things. And of course, I don't want to change own the files to someone that cannot do a change own, and using myself as binary owner, I'm on the safe side here. Also, the su command here is overwritten to just run a shell command and not do anything special here. So This is really a bit shortened version of the whole file. The complete one can be found in the proceedings or on the web. It's just you need to do some settings to the package source system to make it work as root, but it's really not difficult to do, and it works, so you don't need root. Maybe a few words on what's happening behind the scenes. You have seen that the system, when I'm typing make, is already doing a lot of things, and each of the things can be done individually too. It just will know, okay, this steps are needed first, and they haven't been done, so I have to do them on my own. And of course, you can run the certain steps on your own. So the first one is make fetch to just download the sources. Whatever a package build instruction contains a source pointer URL, it will download it from there. Make checksum will ensure that the downloaded source is properly integrity. And well, the next step done by the system is make install depends, which will install dependencies. Programs, packages required to build, to compile a certain piece of software. So this is really where the dependency handling is coming in. After that, the sources are unpacked. You can do that with make extract. If there are certain patches in the package source system, they need to be get applied next after unpacking. This is usually what make patch does. From the package source system, we usually try to send back packages to the original program maintainers, so future releases can incorporate these patches, so we don't have to maintain them on your own, and that everyone using this software now then can benefit from the patches that we feed back. So we are not sitting on our own patches just to have them and say, oh, we are cool. No, we try to feed them back because it's also less maintenance overhead on our side. After the sources have been patched, well, configure the package has to be configured somehow. You, of course, now know how to configure. You might know iMake or the MKMF. If you have looked at like Perl or Apache, there are other configuration managements that need to be paid attention to here. Next, the source is compiled. You can do that with make build or just make. And after it's been compiled, make install will just put the files into place and register the package for use as we have seen. There are a few other targets that might be of interest. After you have installed a package, there is a make package target, which produces a binary package that can be installed on another machine or reinstalled using package add later. After you've installed a package, well, the unpacked sources are still there, and you can clean it up with make clean. You can also say make deinstall, which is about the same as running package delete. It's just a bit more convenient if you have just installed something and find out it's not what I want. Make deinstall is a bit shorter to type than package delete than the package name. For package maintenance, there are two targets here. You can, if you have a stack of package dependencies and you want to replace the one on the base, well, you have two choices. Either you just pull it out and push the new one in. Maybe this will work. It depends on the software. You cannot tell this in the front. This is not a package source specific problem. You also have this in Linux and everywhere. Really, to just pull it out and push in the new version is what make replace does. And if you say, I don't know if my application still works with the updated binary and they have to interact properly, you can say, okay, I want to compile all the software needing this package, and this is what make update usually does, if it works. Yeah. So there are ways to also update the whole system, of course, that way. The whole application software, not the operating system. Maybe an overview of what's available in package source. As you have seen, it's a two-layer system with two levels. The package source system itself has a number of categories, and each category has a number of package directories in there. This is an overview of available package categories like, well, archivers, chat systems, emulators, ember math things, news, printing, time, everything. It's just some sort of categories. Here's an example of the web category. It's not complete. So you have a whole lot of Apache packages in there, Jakarta, Perl modules for web things, everything. You can go in each directory. Oh, I want Apache Postgres authentication, and it will just install probably Apache and Postgres if you haven't already installed this. So package dependency system is used here too. If you're wondering how many packages are available in package source, you have two things to look at. I've looked at the number of makefiles in here, and this is about 5,100 in start of December. You have to pay attention a bit. There is a WIP work in progress category that's not officially part of package source, which has about another 1,000 packages. So it's about, the total is like 6,000 packages that you can install using this system. And there's little software that you will not find in. It's KDE, of course, Apache, Mozilla, Firebird, OpenOffice, Java, I don't know. So it's basically complete enough to be working for practice. Yeah. When we time-wise, okay. Maybe for those that are still sitting here that I haven't scared of, maybe a few details on the internals of the system, how it works. The whole package source system really is based on makefiles. Makefile as build instructions, as you probably know them for regular software, and we also use make here really to do all the steps that I've described here. And just really, there are a lot of common operations that you have to do over and over again for each type of package, like new configure always unpack, run new configure, then make, or X configure needs some other scheme to run. And we do just set some switches here, and the system will then know, okay, I have to run new configure or some other method here. And this is what all is in the package makefile. I've used the X11 xteddy makefile. Don't know if any one of you knows xteddy. It's a very small teddy bear and a small graphical application. It's really a nice toy. If you forgot what xteddy is, there is a comment in here. Xteddy is a cuddly teddy bear for your X Windows desktop. Yeah, each package has a maintainer that you can talk to, and where we know a homepage, we will remember it. There's also a master site, which is maybe the same as the homepage, but with mirrors and things that might be extended. There are a few settings. The program here needs X, and well, it uses GNU configure. Before we can do installation, pre-install, we make some data directory, and the package itself needs the XPM library here. After that, we pull in with include here a certain file that really has all the intelligence to do the package handling. This is really the package source engine here. In the meantime, it's been split into a few files that are fetched in behind the scenes. And this is really what the build instruction for the package itself is. That one can write on its own. And when creating a new package, only this needs to be made. There is nothing more here. For dependencies, there are actually a few ways to do. There's a type of dependency that are okay to just have at compile time, where you say, okay, I need a special compiler or something like Fortran. And I don't want this compiler installed when running the program. So this is what the build depends are. And there's also a compile and runtime option for normal depends, where a package can say, okay, I need this package installed to build and to run. An alternative that's growing in NetBSD or in the package source system is the build link files, which is really just a snippet that comes with a library. And this build link files say, okay, if you want to use this library, you find the headers there, and you need these command line switches for linking, for compiling, for for doing other things, and maybe if you need some more dependencies first for library, they will also know this and pull in the right settings again. So this is really just per library information that will be pulled in. Examples here, well, it's variables for the KDE package, which is just we call it a meta package. This will just pull in other packages like KDE accessibility, please in this version, and separated by a colon, if it can't be found installed, well, there is a certain directory given relative to the current directory where it can be found, and well, if it's not installed, then change to that directory and type make install. This is what the system will do automatically. Next, it will check if KDE 8 artwork is installed in this version. If not, it will change in that directory, make install. And so on, and really just install all the packages needed for KDE 3 in this case. So the syntax is here, a package including a version. This can also be a wildcard, and the directory within package source needed to install. The building files, I've already said, contain information for like what header files to use for, what libraries to use for a certain package to use it, which version, which library name to link in, and a lot of other things like CPP flags and so on. And just have a look at this is a complete building file for using the TIFF library. And basic things that you hear is okay, it's called the TIFF library, and it will also say, okay, I would like to have TIFF in this version or bigger here. If it's not found installed, it's about the same like before. You can change to this directory, but you can also say, okay, TIFF in turn needs the setlib library and the JPEG library here. So this saves a few things. When you have a lot of packages that need TIFF, you can just pull in this file everywhere. And if the dependence list of TIFF changes, you just have to maintain one spot and not many. Yeah, I'm already at the end for this. This was a very short introduction of the package source system for you, showing you how you can bootstrap it, how you get started, with a special emphasis on not requiring root privileges. You don't want to thrash your system when playing with application software. It's not needed, as you have seen. I've also installed Apache and a lot of Apache modules. They don't need root privileges. So I've put a few URLs here if you're interested, www.packagesource.org, or of course, as the package source project comes from NetBSD, you'll find a lot of information at the NetBSD site too. There's also info at packagesource.org. If you have any specific questions, we will go to that. In the Hack Center down, we have a NetBSD booth, and we have also some printed documentation for a package source, and all this is available. So, well, now I'm really at the end, and are there any questions? Anyone?
Hello. Is there an easy possibility to update all installed packages?
There are a number of configuring scripts that do exactly that. That test what software is outdated that's installed right now and give you a list of what needs updating. And there are tools for that. So you can just do like a CVS update of the package source tree and say, okay, this and this package is outdated, it was updated in the package source system, I want the new update, and you can have it. Any other questions? Yes? Here, have fun.
Does it work together with the native package management systems on the host OS? No.
No.
So you have
completely our own universe. We have tried to look aside on what's installed on the base system, and to some extent we also do this still for like OpenSSL or a few things. But really it won't interact really good with another package system. So we'll just check if this a very small set of applications available. If not, okay, we will do it on our own. Because in package source we know how things will get installed, and if we rely on some non-package source system, we still don't know what we will get. We have had that with the tech info system, that info directories, and it was just a nightmare. And we said, okay, no, just no. Any other questions?
Are there good binary repositories?
Pardon?
Are there binary repositories for?
Yeah. There are at the ftp.netbst.org. There is a big binary repository for netbst binaries and in pub netbst packages. And there is also a repository in pub package source, which is a growing repository for non-netbst packages. A lot of binary packages for Sun, Solaris, also I think a lot of Linux binaries, and for IRIX also there are binary packages available, and I have to admit I've lost track of what there is exactly. For Sun, I can tell you we support both Spark and Intel-based system or Octoroon-based systems, and there's definitely a lot of binary packages there. And if not, you always have the choice to recompile it on your own. So this is really the strength of the system. You can combine binary packages. Also say, when you are installing dependencies, there's a way to say, okay, try to, or look if there is a binary package available in that repository. Well, if not, okay, build it on your own. But if it's there, hey, use it. That's possible, very easily, one line. Okay, other questions? Okay, then I would like to thank you very much, and if you have further questions, the NetBSD booth in the basement will have all the answers you need.